Today we're going to talk about the periodic table of elements. Periodic table of elements is a chart or a device that we use to group together the 118 elements, and it organizes them in a couple different ways that leads us to be able to predict how they're going to react to each other, and it tells us quite a bit of information about each element. First of all, the groups or the periodic table is arranged in rows and rows and columns. The rows are called periods, and the periods uh, are give us details about which electron shell we're filling. There are eight atoms have anywhere from 1 to 7 different electron shells, and how we fill how they're filled is determined by the row or the period. Groups, which are the columns, are arranged according to how the element reacts with others. So, in the case of this first group, which hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium all react similarly. In fact, they all are very, very reactive elements, particularly with this column over here, because this column has one electron in its outer shell, and it wants to react. It wants to donate that electron to another atom so that it can have a full shell configuration like these on this far column. Fluorine and chlorine and bromine and iodine and so forth all need one more electron to achieve that full shell of 8 that is represented by this column here. And so it wants to steal one. These want to donate one. So they react very violently and very strongly with each other. This first row is called alkali metals, and like I said, they're extremely reactive. They all have one electron in its outer shell. The second row, the second column is, or group is, called alkaline earth metals. Each one, beryllium, magnesium, calcium, strontium, barium, and radium, all have 2 electrons in their outer shell. These in the middle that go across here are called transition metals, and they are, as named, they are have characteristics of metals. You have iron, nickel, copper, gold, silver, vanadium, titanium. They're all metals like we classically think of metals. They're shiny, they're malleable, they're conduct electricity, and they're good thermal conductors as well. Now, when we get over to this column, we have boron, aluminum, gallium, indium, and so forth. They have 3 electrons in their outer shell, and the carbon, silicon, germanium, tin, and lead, and fluvium have 4, and so forth. And nitrogen, phosphorus, arsenic, Antimony all have 5, oxygen 6, sulfur 6, selenium 6, and fluorine, chlorine, bromine all have 7. And finally, we get to this column here, and that is they all have full shells. Now these right here, from here to right there, are called they're metals, but they are starting to transition away from being full metals. They're mostly metals, but they're starting to show or exhibit some qualities that make them not quite as good conductors or thermal conductors that these transition metals are. This here in blue are your nonmetals. That little triangle, those are your nonmetals. And that's oxygen, nitrogen, carbon, sulfur, phosphorus. And then these green right here are called they're called metalloids. Now those are some of the most interesting ones because they have properties that are similar to metals, but they also have properties that are similar to nonmetals. They are called, another name besides metalloids is semiconductors. And that's indeed what they're used for in computer and electronic equipment, that we take advantage of their ability to resist the flow of electricity somewhat, but not fully. This second to last row, group 17, are called the halogens. And this last row, I said, had a full shell of 8 electrons. So they don't like to react with anything else. They like to set themselves apart. And that's what gave them the name noble gases, because they were too good to react with any of these others. So they were being, setting themselves apart. Now, if you noticed that we have 2 rows down here, this is the lanthanide series, and this is the actinide series. And they put them down here out of convenience. If you notice right here, you have 56, and then it jumps to 71. Well, this lanthanide series, 57, 58, all the way through 70, fits in right here, okay? Fits in right in between there. And radium is 88, and lawrencium is 103. So we sneak in this actinium, thorium, uranium, neptunium. We sneak those in between there. And the reason they did that is because if we had included them in the periodic table like everything else up here, the table would be very, very wide. It'd be very cumbersome to handle and to display. So it's just out of a matter of convenience that they are displayed down here. Now, I hope this was helpful. And if you have any questions, please hit the comment section, and I will respond to your comments. I appreciate it. Thank you.